Welcome in, everybody. You are listening to the WeCyberYou Unlocked podcast.
Glad to be here.
Yeah. And real quick, before we jump into today's deep dive, make sure you follow the channel so you never miss an update.
Absolutely.
And of course, head over to WeCyberYou.com for more content just like this.
Lots of good stuff there.
For sure. So, okay, let's just get right into it. Today's mission is all about WFs.
Right. Web application firewalls.
Yeah, exactly. And we're going to unpack what a WEF is, how it works, and really why it's basically this critical shield for the entire digital economy right now.
Because, web apps are everywhere.
Oh, totally. Online banking, social media, your company's SaaS platforms, they're all just constantly exposed to the open internet.
Constantly under attack. Yeah.
Right. So, okay, let's unpack this with an analogy. A traditional network firewall is sort of like a bouncer checking IDs at the door of a nightclub. Right?
Yeah, that's a good way to look at it.
Like they're only really looking at the outside, the IP addresses, ports,
yeah.
The protocols.
Just making sure you have an ID.
Exactly. But a WAF is more like having an undercover security guard actually inside the club.
Right, mingling with the crowd.
Yeah, watching what people are actually saying, what they're doing, their behavior.
Which is a huge distinction because, technically speaking, unlike those traditional firewalls, WEFs are operating at the application layer.
So that's layer 7, right, of the OSI model.
Spot on, layer 7. And that's crucial because it allows the WAF to actually inspect the real content of the HTTP and, HTTPS web requests.
Before it even hits the server.
Exactly. It's looking at the actual responses and requests before the server has to deal with them.
Okay, so let's get into the how-to of that. What exactly is this undercover guard evaluating?
Oh, man, it's looking at everything. URLs, the headers, cookies, query strings.
Forms, I'm guessing?
Yep, forms, API calls, any uploaded files, session info, even just like overall behavioral patterns.
Wow. Okay, so based on all that, the WMA makes a call.
Right. It follows this rule set. So it might allow the request, it might block it, maybe challenge it with a CAP DCHA.
Or just log it.
Yeah, log it or rate limit it if it's suspicious but not overtly malicious.
But wait, let me push back on that for a second.
Sure, go ahead.
Because if a web request is really just, mostly a string of text, how does the WAF actually know that a specific text string is an attack?
Like, how does it know it's not just normal user input?
Right. Because I type weird stuff into search bars all the time.
Yeah, no, it's a great question. And it really speaks to how WAFs have had to evolve.
Okay.
So first-generation WAFs, they relied almost completely on manual rules.
Like hard-coded stuff?
Yeah, what we call signature-based detection.
Okay, got it.
It's highly accurate for known attacks. Like, if a WAF sees a very specific malicious script that causes cross-site scripting or XSS...
He flags it.
Right, or token manipulation that leads to, cross-site request forgery.
HRF, yeah.
Exactly. Or patterns that look like a remote file inclusion, which can trigger remote code execution.
That sounds bad.
It's very bad. Or, directory traversal, where attackers literally just try to read sensitive server files by using ... patterns.
Oh, wow. So if it matches the signature, boom, it's blocked.
Right. But the problem is it's completely blind to 0 days. If it's a brand new attack, there's no signature.
Ah, okay. So is this essentially the difference between having a VIP guest list and a do not fly list?
That's exactly what it is. Those are the two core security models.
Okay, break that down for me.
So your VIP list is the positive security model. We also call it a whitelist.
Gotcha.
Only known, explicitly good traffic is allowed in. It's incredibly secure, but man, it requires intense tuning.
Because if you forget to put a good guy on the list, they're blocked.
Exactly. Legitimate users get dropped all the time if it's not tuned perfectly.
Right. And the other one?
The negative security model, that's your blacklist, or the do not fly list.
Okay.
Known malicious patterns get blocked. It's way easier to deploy, but like we said, unknown attacks just slip right past it.
So obviously neither of those is perfect on its own.
No, not at all. And what's fascinating here is how we've upgraded. Modern waves don't just rely on lists anymore.
They're smarter now.
Much smarter. They use behavioral analysis to basically baseline what normal behavior looks like.
Like typical login rates or where the user is geographically.
Exactly. And they use machine learning to detect emerging threats and fraudulent transactions based on anomalies in that baseline.
Okay, here's where it gets really interesting to me, though.
Yeah.
Because we're talking about web pages, but what about mobile apps? or modern software that doesn't even use a standard website.
Oh, that's the big shift.
Right, because my banking app on my phone doesn't look or act like a normal web page to a server, does it?
No, not at all. And that is where API security comes into the picture.
Okay.
Almost all modern apps run on REST or GraphQL APIs.
Basically just raw data streams, right?
Exactly. And attackers love targeting APIs because they expose so much sensitive business logic and it's heavily, heavily automated.
So how does a modern WAF handle an API if it's not a web page?
It has to do things like API schema validation. It actually has to understand the structure of the JSON payload.
Oh, wow. So it's looking at the actual code structure.
Yeah, and doing deep token inspection. Plus, a huge part of modern WAFs is discovering shadow APIs.
Wait, shadow APIs?
Yeah, endpoints that developers spun up for testing, maybe forgot about, and never told the security team about.
Yikes. That sounds like a massive backdoor.
It is. And connecting back to that automation piece, you have to realize a massive amount of internet traffic is just bots.
I mean, I know search engines use bots to index sites, right?
Right. Googlebot is good. We want Googlebot.
Yeah.
But a WAF has to identify and block the bad ones.
Like, what are the bad ones doing?
Malicious scrapers, stealing content, credential stuffing bots just hammering login pages with stolen passwords.
Oh, trying thousands of passwords a second.
Exactly. Or inventory hoarders, and concert tickets sell out in 2 seconds.
Yes. Oh my gosh, that is the worst.
Bots. So the WARF has to use really advanced client fingerprinting and, CAPTCHA challenges to shut them down.
Okay, so physically speaking, where is this all happening?
What do you mean?
Like, are we talking about a big metal box sitting in a server room somewhere, or is this just code floating around the cloud?
Oh, I see. Well, it depends. There are really 4 main deployment models for a WAF.
Okay, run through them for me.
Sure. So first, you have cloud-based. Think of like Cloudflare or AWS.
Oh, sure. Super common.
Very common. It offers massive global coverage and it's easy to scale. Then you have the reverse proxy model, which sits in front of the web servers and does really deep inspection.
Got it. What's the third one?
Host-based. Something like mod security. It's installed directly on the web server itself.
That sounds like it would give you a lot of control.
Very granular control, yeah. But the trade-off is it eats up your actual server resources. CPU, memory, all of that.
Right. It competes with your actual app. And the last one.
Hardware.
Yeah.
Literal data center appliances.
Okay, the metal box.
Yep, the metal box. Huge throughput, very fast, but definitely less flexibility than cloud models.
Makes sense. Now let me ask about DDoS attacks, because I feel like people confuse WAFs and DDoS protection all the time.
Oh, constantly. It's a huge point of confusion.
A WAF doesn't stop a massive DDoS attack, does it?
Well, it mitigates layer 7 HTTP, and API floods the really complex application layer stuff.
But if someone just throws a terabyte of garbage traffic at your IP...
Right, massive volumetric DDoS attacks. A WAF can't handle that alone. Your internet pipe will just choke.
So what do you do?
You still need content delivery networks, CDNs, and dedicated scrubbing centers to absorb that kind of brute force.
Gotcha. Okay, I want to go back to something we touched on earlier.
Sure.
The tuning part. Because to me, it sounds a lot like an overzealous spam filter.
That's a great analogy, actually.
Like if a user types something really weird in a search bar, maybe they're searching for code snippets, couldn't the WAF just block them thinking it's a SQL injection?
Yes. False positives are the main of every security engineer's existence.
I bet.
And that's why the WAF management lifecycle is so critical. You don't just turn it on and walk away.
So what's the life cycle?
You start with planning, obviously. But the big one is deployment in monitor mode.
Monitor mode. Meaning it's watching but not acting.
Exactly. It logs what it would have blocked, but lets the traffic through so you can see if it's breaking legitimate stuff.
Oh, that's smart.
Then you move into the tuning phase, fixing those false positives. And finally, it's just continuous improvement.
Constant threat hunting, I assume.
Yeah, because the threats never stop evolving, so your WAF rules can't either. You have to constantly balance security with usability.
Right, because if your app is perfectly secure, but legitimate users can't buy anything, you're out of business anyway.
Exactly. And, if we connect this to the bigger picture...
Please do.
A WAF is not a silver bullet. I want to make that very clear.
It's just one piece of the puzzle.
Right. It absolutely cannot fix inherently insecure code. If your developers write bad code, the WAF is just a Band-Aid. Organizations really must view it as one layer of a defense-in-depth strategy.
Makes total sense.
And honestly, today, the platforms from the top vendors, Cloudflare, Akamai, F5, Palo Alto Networks, Imperva.
The big players.
Yeah, they've evolved way beyond simple appliances. They're these unified application security platforms now.
Encompassing all the stuff we talked about.
Exactly. Bot management, API security, and all these zero trust capabilities built in.
Wow. Okay, so what does this all mean for you, the listener?
Yeah, why does it matter to the everyday user?
Well, as long as we rely on the cloud and mobile apps for literally everything, the WeF is really that foundational digital shield.
It really is.
It's the thing actively protecting your personal data, your finances, your privacy, every time you tap a screen.
Working quietly in the background.
Exactly. But I want to leave you with a kind of provocative thought here, based on something we brought up earlier.
Oh, okay. Let's hear it.
So modern waves use machine learning to learn, normal human behavior, right?
Right. The baseline we talked about.
But as attackers start using generative AI to perfectly mimic human browsing habits, like adding little pauses or erratic mouse movements.
Oh, wow. Yeah.
How will a WAF tell the difference? Like, are we rapidly heading toward a future where our WAFs are literally just our AIs fighting their AIs in milliseconds?
That is, wow, that's kind of terrifying, but probably true.
Right. Just machines fighting machines while we try to buy concert tickets.
Yeah, that's a wild thought to end on.
Yeah. Well, I think it's a good place to wrap up today's deep dive. Thank you so much for joining us, everyone.
Thanks for having me.
And remember, head over to WeCyberYou.com for more deep dives. And definitely follow the WeCyberYou Unlocked podcast channel. We'll see you on the next one.